Okay. All right. Welcome everyone to our episode here with Kasun about Santa's workshop Magic with AKS and Bicep. Before starting and kicking off our session with Festive Tech Calendar for 2024, I want to say big thank you for organizers for putting this together. As it's a time where our tech professionals and MVPs across the world are donating their time to make a festive sessions for everyone. And this time with Kasun, we teamed up and we say, let's, hit the road here and put another festive session with the technologies that we think Santa can have and use for their benefit. Anything else, Kasun, you want to add? And before greeting everyone who is watching our session today.
Yeah, so it's very excited to be part of this session. So we will hope that viewers will have some good time from this session and will learn new things about.
And yeah, that's great. And we want to you get entertained, right? So festive tech calendar session, not just about dry tech here. So I hope you
Yeah,
can catch some of the jokes. If you don't, put them into YouTube channel comments and we'll address them. All right, let's
yeah,
kickstart and unwrap this for everyone. All right. Okay, so first thing, why we are doing that, right? Why Santa would need actually AKS and Azure Bicep. As you know, a holiday season is approaching very fast, and Santa has a workshop that's buzzing with excitement to get everything ready. And as you see here on the picture, we have elves and some humans, namely cloud engineers, who are hand in hand working to deliver those presents to the people all across the world, and especially the small kids. So as you see, there's a gift hunt wrapping that's going on. That's making sure that the high tech is used in wrapping them up in a way that everything is fresh and undamaged, and it's provided to you. There's a wonderland of events where we have of course, cloud operations and IT magic that's happening behind. When we say cloud operations, we refer into the all the systems that needs to run, on time and with good availability, so that Santa operations, namely wrapping the gifts, making everything ready for the big delivery day, is running smoothly. And as an IT magic behind, as you may, imagine, there's entire operation that needs to run clockwise, and plus there's advanced data analytics and tracking gift requests, monitoring inventory. All these things needs to be tracked, and cloud engineers are behind the scene doing this IT magic for everyone. And of course, there's a big delivery day to of these gifts to everyone. And again, during that time, IT team is going to monitor the sleigh and how Rodolphe is actually, carrying all these gifts into the destinations by tracking the GPS and stuff like that. To automate all of this and make sure that, the workloads, the basically the work that needs to happen and deliver and track all this is in place. This year, Santa's Enterprise actually running everything with the cloud, and it's a challenge for them to deliver. But we have some suggestions for the Santa here, and let's dive into that suggestions how we can make it easier by passing the torch here, by passing the word to Kasun so he can talk about what we are introducing for Santa's Cloud Enterprise this year.
yeah. So we have some big task for us to achieve. So for to Santa to help to deliver his presence to the people around the world. So in this session, actually, we will learn about how we can what kind of things we need to consider when provisioning AKS cluster with using biceps. How we can use uh, how we can address different challenges when it comes to the Santa's enterprise. So this include how we can automate through Bicep the deployments of cloud infrastructure and how we can do the right scalability. What are the things we can take a look at to scale the cloud infrastructure in a case and monitoring security and other features that we will need to know about when you deploy the clusters.
Awesome. Yeah, that sounds great. I hope it's interesting. So it's all about diving into AKS, managed Kubernetes, as you know, and how infrastructure as a code, Bicep in this case, is going to be hand in hand used for this delivery. Okay, that said, some of you may not know what's Azure Bicep, right? Maybe you're, hearing about this IT technology first time. It's a actually infrastructure as a code language. So let's, a little bit dive into that and show sample of Bicep so that you can associate what is this Bicep, where this Azure Bicep came from. First of all, Azure Bicep is a domain specific language, DSL, meaning that it's created for specific purpose, and the purpose is to manage and create easily resources, cloud resources in Azure environment. It's something that's a transparent abstraction over ARM is the Azure Resource Manager, which is a layer in Azure Cloud environment that's manage the authentication, authorization, as well as sending this final HTTP request into the Azure provider services that are actually creating the resources or managing them, maybe updating, not always creating, right? And sometimes deleting the resources when you are done working with them. And then, of course, and the Azure Bicep language itself is a new way of doing infrastructure as a code in Azure Bicep. Doing infrastructure as code in Azure, you can also do that with ARM templates and some other technologies, and we are going to mention them. But before going too much into that, let me share a screen from my Visual Studio Code where you can see how it looks like to have a Azure Bicep code. So in this example, if you look, it's a small example of provisioning certain resources in uh, Azure environment. Namely, any resource that you provision in Azure environment, it would require a resource group, right? And then it would require some resources to be provisioned there. To have a very simplistic example here, as you see, there are different scopes where you can deploy your Azure Bicep code, which is defined here. You can have these descriptions and some validations like minimum and maximum lengths of the certain parameters that you want to deploy. In this case, we set a resource group by the name RG resource demo. It's here. Let me make sure I can zoom in here appropriately so you can see that much better. Here it is. Sorry for inconvenience here. So let's see. So here in this line, so as you see, this is what I was talking about, where we define the resource group and we define the description and everything. And then if there's if you want to make sure that only certain regions or places could be used to deploy your resources, you can always, select this uh, set of resources that you want to be used as part of the deployment. In our case, we want to, for example, deploy to EastUS2. And then once you define that, and this is the default value that's picked up from there, then you can define actual resource. So all your resources basically use the resource keyword. Parameters come with the param. So that's all kind of, clear to us. I hope that's all clear to everyone. And then under the resource, you have the provider and resource type that's defined here with the API that's driven here. And then, of course, you have parameters and configuration of the resource. So if we go back to there in this, at least in this sample here, we have two resources. We deploy the resource group parameter with the name that we define. And then inside that resource group, in this example, we are deploying a simple storage account that's using a module. So Azure Bicep comes with modularization, where you can define your resources, and then basically like a Lego, from different pieces, from modules, you can build actually your project. You can build your actual deployment of the workloads, where you can have hundreds of resources in the deployment. So and it doesn't end here. So we also have a visualization that's built into the Azure Bicep, uh, language, where if all this code is strange to you, but you want to quickly see what you will get out of deployment of it, there's also visualizations that you can use. We call visualizer, Azure Bicep visualizer, that's here. And in order to get that working, again, what you need to do, you just need to install the Azure Bicep extension and press on this icon. And when I say Azure Bicep extension, here under the extensions, if you go and type Bicep, You may see one. If it's not installed, you want to make sure it's installed so you can have access to that. And speaking of these demos and of the demo and code, you are going to be able to access them from the description in our session, in our video. We are going to provide GitHub code links. I hope that's kind of makes it a bit easier to understand what's the bicep, so it's not strange to you. If we kind of, spoke about that, let me also give a small introduction to the AKS and what it is. So AKS is Azure Kubernetes Services. It's a managed service for Kubernetes to be provisioned and deployed in Azure environment. And there are different ways how you can actually go and deploy the Azure Kubernetes services into the Azure. For example, there's AKS Automatic. That's one option, which is in preview at the moment that you can use. There's a classic way or a traditional way to deploy your AKS using Azure CLI, command line tool, Azure PowerShell, and as well as the from Azure portal, right? Using by clicking on the menus. Then we have if you want to do it with a little bit of spice of bicep in between, then you can use bicep Kubernetes extension. That's also in preview, but it's there for you to experiment and see if it's the right way for you to choose. And then we have traditional bicep template that you can create this Azure bicep code, which I'm going to show you in a minute. And there are some other infrastructure as a code tools. Maybe you are more familiar with Pulumi or you are more familiar with Terraform. At that point, you can still use those different ways or third-party tools to deploy AKS resource into your Azure environment. Okay, that said, let's look at another code here in Visual Studio Code. In order to get that one, it's a learn bicep repo, which we are going to share. Just go to this deployment 22, test number 22, where you basically, what we have here, it's a more of a less boilerplate. I have this definition here if you want to understand what exactly it's doing, but it's basically defines these parameters, right, before deploying your AKS resource, and then it defines some minimalistic properties. So again, Kasun is going to dive more into details of each feature, why you need them, and what's the, recommended properties there. But you get into each feature of these properties and features of the AKS service in order to get it running, to get it deployed in a configuration that your workloads require. That said, for this one, we can also use Azure Bicep visualizer magic here. As you see, the resource that's here on the example 22 deploy AKS just deploys the AKS managed service. I hope that kind of clears out for you how does Bicep look, Bicep as an infrastructure as a code, and what's the AKS on a high level, and what are the ways to deploy it. But if you want to dive deep, if you want to compare each way how to deploy them and how it's working, there's a resource here on Microsoft Learn that we are going to share, and you can, for example, if you want to experiment with Azure Automate, if you want to rephrase, if you want to again experiment with AKS Automatic and how it works in preview, what's the way to set it up, and what are the requirements, you can check this on this website. These other ways how to deploy, we are going to share the link for you. All right, that's it. Now let's look into managed Kubernetes in more detail with our friend Kasun here. Go ahead, Kasun.
Yeah, thank you. So as Khan mentioned, so Kubernetes is an open source project. Uh, Now it's about 10 years old, but it got a lot of attraction from the community, and therefore Microsoft also um, create their own managed service, because Kubernetes is a little bit complex to set up. If you are using pure Kubernetes, then there are a lot of complexity around it to set up. So to avoid that complexity, Microsoft will introduce the managed Kubernetes service, which will increase, that means it will make easy to provision Kubernetes in the cloud, especially this in this case in Azure, and deploy your application very quickly, and you can use it uh, to deploy your application there, right? So when you talk about managed Kubernetes in Azure, so when you talk about Kubernetes, there are mainly three planes. One is control plane and worker plane. So in managed Kubernetes, what they happen is the control plane components will be taken care of by Microsoft and Azure team. So they will make sure that control plane is high available, and all the control plane components like HCD, API servers, and everything will high available and uh, available for your workloads to access, right? And as a customers, we need to concentrate on worker plane, that is basically the nodes and other configurations. So we have some abstractions that are handed over to the Microsoft to manage. That is what managed Kubernetes mean in basically. So with the managed Kubernetes, there are some advantages and enhancements that we are getting, such as automatic updates, right? So every six six months there will be a new Kubernetes version is releasing. So uh, we can make our cluster update automatically based on that release, and um, it will also uh, simplify the Kubernetes upgrade to this automatic upgrade process, because updating Kubernetes will involve a lot of things. So, but this with this managed service, the automatic update will be much more easy. And in this screenshots, you can see how we can put enable automatic update in the Bicep. So I will show them again in the demo when in the at the end. But in here you have the um, snippet how we can enable the upgrade option, right? Then the difference between Kubernetes, as I mentioned, manage and no, default Kubernetes is showing in these other two images. In the AKS managed cluster, you cannot find any pods related to HCD or API server schedulers, because those are managed components by Microsoft. So we don't have access to those components. But if you take a traditional Kubernetes cluster, you can see the component like HCD and API server scheduler components available for you to um, work with, right? So that's basically what's managed Kubernetes means. Then there are additional components like uh, scalability and high availability. So these are also inbuilt to manage Kubernetes, because we need to make sure that our application, the enterprise application, in this case, Santa's delivery applications and all the other applications are high available and scale on high demand, right? So therefore, with managed Kubernetes, we have cluster autoscaler inbuilt to the case. So therefore, we can scale your cluster nodes based on the workload's demand. So it is much more convenient, because if you are using traditional options, then we need to do a lot of um, behind the scene configurations to make this cluster autoscaler work properly. So, but with power of cloud and managed service, we can enable this much more easily. Then the other one is availability zones, because you have to make sure that your application is highly resilient for any zone failures within the Azure environment, Azure zone regions, right? So you can distribute these cluster components like worker nodes into multiple available zones within the region. So if there are any unavailability or failure happen in specific zone, it will not impact uh, it will not impact your application, uh, because your works and workloads and components are distributed among multiple availability zones. In this snippet, you can see you can define which availability zones you need to distribute. These numbers will be depend on the availability zones in the region. Some availability zones may have more than three. Some some regions may have uh, three availability zones. So then the auto scaling also you can enable through bicep by adding the parameter enable auto scaling. Then also you can put auto scaling options like how how much nodes you need to auto scale, right? The minimum count and maximum count of uh, nodes that need to be available for auto scaling. Okay. The next one is actually add-on profiles. So Kubernetes has a lot of add-ons available for you to use. So Kubernetes add-ons actually manage add-ons. So these manage add-ons will help us to deploy some Kubernetes native applications, native tools uh, with more easily, because as I mentioned, some of these tools, setting up these tools may require additional configurations and a lot of lot of works you have to be accomplished. So by using these managed add-ons, Microsoft will make sure that these components are deployed to your cluster based on the best practices and highly available approach, so automated approach. So you can you don't have to worry a lot about how these components are work, um, how they are deployed, but it will make your deployments easy when you use managed add-ons, right? So there are list of Microsoft managed add-ons available, so you can find them in this list, right? GitHub link. So to mention few, one of one of them are like Istio add-on, then uh, we have HTTP application routing. Basically, it is the Nginx ingress control add-ons, right? So if you are using Nginx ingress controller with self-hosted approach, then HTTP application routing is the managed Azure add-on for ingress controller, right? Likewise, there are different add-on like key vault integration and other add-ons are available for you to use. So in this bicep also you can specify the add-on profiles and specify which add-ons you need to enable for your cluster. Then when you create in the cluster, these add-ons will be installed and you can take usage of these add-ons. Yeah. The next very important thing, we need to make sure that our Santa's cloud journey is observability, right? So when you deploy uh, clusters or containers, there are a lot of abstractions there. So because if you have already experience with containers, so containers are on another layer of operating system. Then when you come to the Kubernetes, containers are on top of pods. Then pods will control by other high level control like deployment, daemon set and kind of things. Then the logging mechanism is different compared to the traditional loggings, right? But that's why we need a proper observability to make sure that our centers cloud journey and AKS journey, so he can monitor, their cloud engineers can monitor the infrastructure, and if there are something goes wrong, then they can take appropriate actions and precautions to avoid any disruptions, right? So When you talk about AKS observability, we can use AKS Container Insight. Uh, then then you can use manage Grafana and Prometheus, right? When you talk about Grafana and Prometheus, it is the de facto mechanism of monitoring Kubernetes. It is one of the earliest projects that are donated to CNCF after Kubernetes. So if you want to monitor Kubernetes, then you have to use, it is very highly advisable to use Grafana or Prometheus. So Azure has a service managed offering of Grafana and Prometheus. Then you can integrate that Grafana and Prometheus with AKS, and then you can have much more visibility on your AKS environment, and you can view a lot of metrics, and based on that you can take a decisions. And even you can use service monitors and to create specific monitoring profiles. Then you can use recording rules. Then you can use alerting options with Azure Alerts, and there are a lot of possibilities to uh, build a good observability option around AKS. And AKS Container Insight also very important. It will allow to collect metrics as well as logs and send it to the log analytic workspace. Then, as a cloud engineer team or a security team, you can view those logs, and if there are any application errors, you can view them and take appropriate action. So I will show this one, the demo as well. So we will take them in the future.
Okay.
Next one is private cluster. So this is very important when you talk about security, because a lot of organization, even in the center enterprise, so they also need, they are very curious about how we can secure uh, the cloud environment, especially AKS cluster, because they are all the applications are running in AKS. So private cluster is an option that they can use to uh, restrict public access to the cluster, right? So in the, if you are using portal, or if you are using normal deployment, then that cluster will be public. That means that cluster API server has a public access, so you can use kubectl command and you can interact with the cluster uh, after deployment. But private cluster will do is it'll deploy to private network. Then it doesn't have a prior public access to the API server. So then you can use your hub and spoke network or your VPN or the kind of the internal network to connect to the cluster. They need to use it will use private links to connect with other resources like key vaults, then storage accounts in any other Azure services that are interacting with uh, uh, AKS private cluster. And for this one, it will use private DNS zones as well to private links, and we can do a lot of configuration, lot of uh, configuration like restrict egress traffic. So you can send you all the egress traffic through your enterprise firewalls, and those kind of things can be done through the private clusters. Private cluster is basically a cluster that we created within our Azure environment that doesn't have access to the public.
And just to add into that, so basically part of this private cluster is also if you don't want your traffic to go through the open internet, but you want that
Yeah.
to go through it's basically hidden from outside, from, other malicious actors. That's where you want to invest into that. Okay, thank you. Next, I will take it here, Kasun, from you for Azure
Yeah.
Key Vault. So
Yeah.
Azure Key Vault is a already established service in Azure environment where you can use that to manage your secrets, keys, and as well as certificates. And because there's already service like that, it makes sense to integrate that with other services in Azure environment. And we have AKS. Of course, AKS does have these certificates, secrets, and access keys that needs to be properly stored for security related matters. And then because AKS already comes, not AKS, because Azure Key Vault come already with access controls and specific roles who can access these keys, manage, update the certificates or see the information. This proper integration with AKS make sure that there's less thing that you have to worry about, and you can use a traditional service in Azure environment called AKS, which is a managed way to which is a managed service to manage your secrets, certificates, and keys. And these are the some screenshots where Kasun is also going to mention about that in the demo. Next, automatic clusters. Back to you, Kasun.
Yeah, yeah. Automatic cluster is a new flavor of AKS cluster. So it is actually mm, still in preview, but it is the way in automatic cluster. So it will take a addition next step uh, in that managed cluster. So it has more abstraction than the normal traditional AKS cluster, right? So in here, what is will happen is when you create automatic cluster, uh, it will deploy the cluster based on the best practices, like all the components are deployed through the Azure best practices, right? Then all the cluster management will be fully automated. That means even the work nodes also automated. So if you are using the normal AKS cluster, you can manage your own manage your node pools. But in this case, the automatic cluster it also automated. Then it will more simplify the configuration, and it's like a serverless experience for you. So you can just go and deploy the case automatic. Then you can deploy the whatever the application do you need. But most of those components are already abstracted again. So there are a lot of potential in this one. So and we'll see how it's coming in
Yeah,
future. Yeah.
correct. Yep. Thank you. And now, without any overdue, of course, as the elves and IT staff of Santa needs all this information to automate, there's a demo, right? That you want to look and see what's happening. So, with any overdue now, turning down to the demo. See you in a bit.
So from this demo, we are going to show you what we discussed previously about how we can configure our AKS cluster through Bicep. So in the presentation, we have discussed about different ways that we can enable high availability and different type of clusters, right? So in this example, Bicep, I will show you some of these settings for you, right? So as a first setting, I'm going to show you is uh, enabling add-on profiles for the cluster, right? So you can see that in this Bicep templates, Ashok AKS cluster resource Bicep file, then there's a separate section under the properties of the AKS. You can specify the add-on profile. Here you need to specify the add-on profile name and whether this add-on profile is enabled or not enabled, right? Likewise, you can add multiple add-on profiles to this configuration. So when the cluster is creating, these add-on profiles will be added to the cluster. Then another configuration I had shared in the presentation is configuring the agent pool node pools and making those node pools highly available between availability zones and enabling those node pools with auto scaling. So in the lines 35, you can see we have agent pool profiles configuration in the AKS resource. Then you have an array. In here, you can include multiple agent profiles with different configuration based on your requirement. For example, if you need different um, agent pools or the AKS node pools for different workloads such as memory optimized, CPU, or AI related nodes, then you can configure multiple node pools like this, and each node pool can be configured with different settings, right? So here you can give an agent pool name. Then the most important configurations are here, right? So if you want to distribute your nodes between multiple availability zones within the region, then you can use the parameter availability zones, and you can specify the availability zones you need to distribute this uh, nodes, right? Then the another important setting we can specify is auto scaling. So if you want to make your agent pool, the node pools auto scale based on the demand and the resource requirements, then you can enable them through this enable auto scaling configuration. Then additionally, you can specify minimum count and max count. So here from the minimum count, you will specify how many nodes do you need to run in the pool, minimum number of node pools that should be running in the node pool. Then the maximum count you can auto scale. The next max count represent maximum number of nodes that can be scaled when the resources are required. Then another settings I have mentioned is enabling observability uh, for the your AKS cluster. So that also can be configured through different resources for your AKS cluster, right? So here I have multiple additional resources are created, so I will briefly explain one these resources so you can get some idea about what are the resources that we need for enabling observability for our cluster, right? So if you want to enable the container insight for your AKS cluster to get the information about your containers, then the metrics and those kind of things, then you have the setting Azure monitoring profile. Then under there you can find the container insights. Then you can specify, are you going to enable the container insight? If you are enabling it, then you need to specify the log analytic workspace ID. So therefore, we required the log analytic workspace. So in the below you can find the log analytic workspace is created as mentioned here, right? Then you can reference the log analytic workspace ID to the referencing, right? Then, if you want to have additional monitoring like by using Grafana and Prometheus, that's also possible because Microsoft has their own managed service for Grafana and Prometheus. So then what you need to do is you need to create a Grafana uh, managed service. So for that, there's a specific resource for the Grafana. Then you need to create a Grafana workspace. If you are using Grafana workspace, then there's another important component is needed. That is your Azure monitoring account, right? So that one you have to use this Microsoft.monitor/account resource and create a Azure monitoring account. So this monitoring account used to send metrics and store the metrics for Prometheus. Then you can connect these metrics, the Azure monitor account through through Grafana to visualize those metrics in a dashboard. So that's what happened from this Grafana integration section. There you can see a integration. Then you can see the Azure Monitor Workspace ID is reference to connect with the Grafana, connect with Azure Monitor, right? So addition, that's the most important components. Additionally, to send these data to Azure Monitor, we need a data collection endpoints and data collection rules. So that's and data collection association as well. So that's why what happened from this line 101 to 1056, right? So here there are three resources. One is data collection rule. So in this data collection rule, I'm specifying what type of data should I should collect, and where should I forward these data to store, right? So here you can see I'm using Prometheus forwarder data source, and as a destination, I'm sending it to my Azure Monitor accounts, and you can see the data flow as well as Prometheus metrics, right? Then I will use data collection endpoint. So this data collection endpoint is used to send data for the data ingestion. So then it will be associated with the data collection rule resources, right? So here you can see in the data collection association, what I'll do is I will connect the data collection rule with data collection endpoints, right? So here you can see data collection endpoint is already in the data collection rule. Then I will associate the data collection rule with the AKS cluster of my AKS cluster. So the AKS cluster can send the data to the Azure Monitor account through the data collection rule and the endpoint. Then additionally, I have some authorization rules, authorizations added. For example, if you want to view the Grafana dashboard, then these um, roles need to be included into the resources. Otherwise, you cannot access the Grafana dashboard. So those are the roles that I already added. So I will share this file with you so you can go and take a look at in detail. Right. Okay. So when you deploy this AKS cluster with these configurations, you can see these resources are deployed, right? So as example, if I go to my clusters, right? So here you can see my monitoring agent. If you go to the monitoring, then you can see container insight and Prometheus both are enabled. So if I go to container insights, you can see all the container insight details. It will show you the CPU usage, memory, and all of these other components, right? So then additionally, if you go to the Prometheus section, then you can see Azure Monitor Workspace and my Grafana instances are also connected to the this cluster. Additionally, if you go to the Azure Logaltic workspace, right? Then if you go to the monitor clusters, so you can see the cluster is there. So I also have additional clusters. So there's those clusters are also specified, included in this same workspace. Then I will show you another configuration I talked about, that is auto upgrade profiles. So here you can see I am going to upgrade my cluster automatically based on the different channels. So here you can specify which type of channel do you need to upgrade your cluster. So you can have stable, patch. Likewise, there are different channels. So based on that, the cluster will be updated to the newest version automatically. Now next I will show you the private cluster feature. So private cluster is basically a cluster which doesn't have access from the public network. So if you want to access the private cluster, you should have a Bastion host in your network, or you have to use your enterprise network that is connected to the AKS cluster private network. So this is more secure, so no one can access the API server and access your resources. Then another Azure resource I have discussed is AKS Automatic. So you can deploy AKS Automatic through the Bicep as well. So here you can see a example Bicep template. So in the SKU, you have to specify the name as automatic, then the tier as standard. So then the AKS this Bicep template will provision uh, cluster with AKS Automatic, right? Then if you provision it successfully, you can see a cluster similar to this. So in this cluster, you can see it is a more high level abstraction of than normal clusters. So we don't have any node pool configuration we can do from the portal. So most of the best practices are already applied, like using a Azure CNI overlay with Cilium, then auto upgrades. Then, for example, if you go to the workloads, uh, you can see different components are already pre-installed, like VPA, virtual vertical pod autoscaler, then CAD operator. So those kind of things are already pre-built into the case automatic and still in preview, but it has a lot of potential uh, to use it for in future infrastructure. Yeah, so that's all for this short demo. I hope you guys have enjoyed. So next we will take a look at Q&As from the audience.
All right. I hope you liked the demo that what you see. And again, if you have any questions, we have a repo, GitHub repo where you can get some actual code. But before finalizing our session, we have some very interesting questions in studio, and they come with Festive team. That's going to kind of re-emphasize how this AKS and Bicep is going to help the Santa, the elves, the IT personnel, and as well as Rudolph, right? The reindeer that's actually carrying all this weight. So that said, let's go to these questions that came from studio, and we hope they are going to lighten up you and give some fun. So question number one here, if Santa's sleigh was powered by AKS, how many reindeer would it take to deploy a cluster? That's very clever question here, Kasun, to you. So what do you think?
Yeah, so it depends on how much weight that they are going to uh,
Carry.
carry on. So therefore it depends there. So but basically you can start up with some specific number of radius, right? So
So if you have
then
like
if you are
small, medium, and height, there are like
medium,
different
yeah.
views of
So
that,
yeah,
right?
yeah,
Yes. So
yeah. So
so
we
you
have
start with
different
the small.
size.
So what's your recommendation? You start with the small. If it's not moving, you just add more small, or you change the skew of the service or skew of the reindeer, right? You get
Yeah,
more stronger Rudolph, and
yeah.
then so it can carry. So it's really depends on the type of workload,
Type of
as
field, yeah,
Kasu mentioned. So it's a tricky question, but we try to answer it. So now
yeah.
question number two. Can we use Bicep to create a virtual North Pole in the cloud? Yeah, that's also a very tricky question. And yes, you can actually use Azure Bicep to create a virtual network and virtual resources in North Pole for North Pole operations, not in the North Pole, but for North Pole operations that will be running in the cloud. Even though that cloud is not going to be snowy and windy like you get in the North Pole, but that cloud, which is IT cloud, will provide those resources to you using the Azure Bicep and infrastructure as a code way to create them. And the beauty of that is that whenever you don't need all these, virtual North Pole resources, you can, with a low effort, you can remove them and save on the operations because you want to remove what you don't use. All right. So next here we have a question: what AKS feature would Santa use to ensure his elves toy production line never goes down?
Yeah, so that's a very good question. So we have to make sure that our toy production line will always running, right? So for that, we can use the features that I mentioned, like distribute your work nodes between multiple availability zones.
Mm-hmm.
Then you using high availability like cluster autoscalers to autoscale a cluster when there's a demand for production of toys, and as well as in the Kubernetes inside you can use HPS, horizontal pods autoscalers to scale your applications inside the cluster based on the demand. And yeah, so those are the few things that we can make sure that your production line will run smoothly without any downtime.
Yeah, without any hiccups there. Great.
Yeah,
Yeah. So availability is your friend, and you can also add observability to have better insights to know that if
yeah,
something goes wrong, you can act accordingly. You can act
yeah.
faster to fix it out. All right, next question here. If Santa's workshop had a Kubernetes cluster, which we hope it is, would the elves be considered nodes or pods?
Uh, I would say pods because then these elves come and go, right? So it's similar to the Kubernetes pods, right? So
Hmm.
pods are ephemeral, so it built for ephemeral purpose. So pods will come and go
Yes.
and destroy. Yeah,
And to explain what kind of from a bit different perspective, so elves are, we know that they are tireless and they will work till the end to distribute all these toys. But when elves a bit tired and they need to step out to have a little bit nap, then another group of elves will step up and then do the work. So there's no disruption. That's where, we compare them to the pods and say that pods are probably going to do that work, that elves are trying to accomplish when you compare with the analogy. And final question here, can we use Bicep to automate the delivery of presents, or do we still need Rudolph for that? And it's also a tricky question. I would say, Rudolph, don't worry, your work is not going anywhere. You'll be part of this festive, event, and you are going to be the main character who is going to deliver all and drive the sledge with all these presents to the people across the world and especially the kids. And in terms of Bicep, I would say that Azure Bicep is just another tool that would that would help to automate the backend infrastructure in Santa's cloud enterprise to make sure operations run more smoother and there's less overhead and less headache about IT systems while they are, to make sure they are working appropriately and you are not experiencing any delays. That said, these are the questions, festive questions that we had in the studio. I want to wrap it up and say big thank you for everyone who is watching this session and big thank you for organizers and as well as to my partner in crime, Kasun here, who is a
Yeah.
Microsoft MVP and he's deep dive into Kubernetes and AKS. And if you have any questions, you can always, contact him.
Yeah.
Kasun, any kind of final words from your end before we finalize our session?
Yeah, so yeah, same. So I would like to thank Elkan and the team who are behind this festive tech calendar. So this effort and it's as mentioned. So if you have any question, you can mention in the comments. Or you can contact me or both of us, right?
Yeah,
So then I think I hope everyone has nice holidays and looking forward to see everyone in the next year as well. And
awesome. Yeah,
everyone, Merry Christmas as well.
yeah. Happy holidays, everyone. Thank you
Yeah,
for watching our session. Thank you, Kasun. See you
yeah, see,
all. Keep us in touch with
yeah.
the comments or questions that you have. Have a great day.
Have a
Happy
good day.
holidays,
Bye.
everyone.
Yeah.
Bye.